Hey, this is John. I want to show you guys some of the changes and modifications I made to the Nerf rival Nemesis. I've replaced the battery with a lithium polymer, as well as 3D printed a custom battery tray cover, including an OLED screen. Motors are running off Mosfets now, as well as an infrared sensor up in the front ammo count. It's configurable between single fire, full auto, and burst. There's a demonstration real quick. Here's burst fire. And single shot. Full auto is about what you would expect. I don't have a chronometer, so I can't tell you the exact velocity that I'm hitting. Needless to say, it's a lot faster than the original, the stock Nerf gun, which is pretty pathetic. Yeah. So if you look up there, the ammo counter is actually decrementing correctly as things get fired. There's a few problems still. This is only version 1. I think the biggest problem is the motor braking hasn't been implemented yet. So if you notice on some of my single shot, the motors are still spinning after it tracks that first shot having left the barrel. So I need to slow those down and make sure that it stops immediately after the first shot to get that a little bit more accurate. I don't like it dribbling out the second, or in the burst case, the fourth shot, just kind of falling out of the barrel like that. Just as well, the 3D printed battery tray cover isn't fitting as well as I'd like, so I plan to tighten that up and make it a full drop-in replacement for the original battery tray cover. Yeah, let me show you guys some of the insides and the actual electronics that it took to get it to this point. As you see on the other side of the shell, I have a few buttons. So I use some little wire connectors in order to get those to easily separate. This is just a rotary knob that I haven't put a handle on, so it's a little hard to twist. And this is just a simple tack switch that I'm using for changing the velocity settings right now. Yeah, I just have those wired to pull ground on GPIO pins. Here's the Arduino setup. It's a little bit of a mess, but I'll show you all the diagram. And I have it passing through the LiPo pack with a 5-volt regulator, so it'll be on as long as the gun's on. Inside here you can see my Mosfets, one for the flywheels, one for the pusher motor. I have them bolted through the shell with the intention of putting a heat sink on the outside if I need to. I haven't seen that need yet. And then I have the main trigger and rev trigger. I have those hooked up to GPIO pins as well. And then output on the top, I have a little 4-pin harness for my OLED display. As you can see, I just have that sticky tacked into my custom housing. But that's another quick disconnect, so I can disassemble this with no problem. Yeah. Oh, and up here in the front, it's probably pretty hard to see, but I have an infrared photo sensor on this side, and this is an infrared LED on the other side, and I've drilled a hole through that barrel shroud in order for the beam to be intercepted as the balls are leaving. Okay, let me explain the main circuit that's going on here. So up at the flywheels we have a positive and negative lead on the motor. The positive end goes to the LiPo. The negative end, instead of going straight to ground, gets interrupted by the Mosfet. So I put it on the center pin right here, which is the drain. Then the source pin would go to the battery ground. We connect a Flyback diode across the positive and negative terms of the flywheel so that when it turns off we don't have any extra voltage flying around. And then Yeah, and then on the Mosfet, we have this last pin, which is the gate. This controls whether it's on or off. Most of the time we want it off, so we'll pull that down to ground with a pull-down resistor, maybe 20,000 ohms or something. And then the rest of the time, we'll let it be controlled by a GPIO pin on the Arduino. The Arduino will either be floating or ground until we tell it a signal, which will be 5 volts, which is enough to tell the Mosfet to basically connect these two pins together, which will allow current to flow from the battery to the flywheels and back to ground, completing the circuit and allowing the flywheels to spin. Because the GPIO pin on the Arduino is a PWM, it allows me to pulse the duty cycle of the 5-volt signal going to the gate, which gives us the variability to tweak how powerful this is shooting. I can turn it up to a full 100% duty cycle, which is max power, or something more reasonable I've found is around 50 to 60%, which is fun enough to play with and not so hard that people are running from me. Alright, and like I said, that's my modifications to the Nerf Nemesis. Version 1, I have a lot more changes in the pipeline, so I hope to keep documenting that, and hopefully y'all can learn as I do.